Welcome to the Last Economy podcast, a guide to the age of intelligent economics. Today, we are undertaking a deep dive into Chapter 10, the network prism.
Yeah, that title, it definitely sets a tone, doesn't it?
It really does. It suggests we're moving into some pretty heavy, maybe uncomfortable territory. And honestly, that's exactly what the book delivers here. For years, maybe decades, we've all kind of operated under this really powerful myth, almost like a religion, that the economy is this, beautiful, flat, level playing field.
The meritocracy idea.
Exactly. Success, we're always told, comes from pure individual talent, grit, hard work, a true meritocracy. But Chapter 10 basically slams that door shut. It argues that the reason so many of us feel like we're running harder and harder just to stay in the same place, well, it isn't really about personal failing. It's actually down to fundamental laws of physics and mathematics that govern how things connect.
And what's really fascinating here, I think, is how it completely reframes economic thinking. Traditionally, we look at economics through the lens of human
People who
psychology.
read, right, rational choices.
Exactly. Fear, greed, utility maximization, all that. This chapter says, okay, let's pause that psychological view. Let's start seeing economics more like a structural engineering problem.
Structural engineering.
How so? It's all about network topology, the geometry, the architecture, the global system. The book basically says, if you want to understand why your individual effort often feels like it's not enough to, change your financial trajectory, you have to look at the shape of the web you're caught in.
So the structure itself.
The structure, it turns out, is the dictator. The geometry matters most.
Okay. So our mission today, for you listening, is to really try and understand why this structural position, this topology matters so much more, maybe exponentially more, than your personal attributes or, how many hours you put in. And we also need to dissect how this age of artificial intelligence, which is accelerating so fast, isn't just changing the game. It's taking this geometric reality and, well, cementing it into what the book starkly calls an inescapable prism.
Yeah, it's about going deep into the math, the physics behind that modern feeling of, well, exclusion.
Right. Let's dive in. So let's start with that central challenge. Most of us, deep down, we really want to believe in meritocracy. We look at successful people, and the default assumption is, okay, they worked harder or they had some unique skill we lack.
It's the comforting narrative.
It is. But if the economy really is a level playing field, why does success, influence, wealth, why does it always seem so intensely concentrated? Logically, if it were random or purely skill-based, wouldn't you expect a much more even distribution, something closer to a bell curve?
That's the logical conclusion if the meritocracy myth were true, absolutely. But the book argues the web itself, the network, is fundamentally structured to prevent that kind of equal distribution.
So imagine it wrong.
We tend to imagine the economy as like this nice democratic grid, maybe a chessboard where every square starts with equal value. But that's topologically false. It's not flat.
Okay.
The economic network is actually more like a topographical map. It's got mountains, deep valleys, critical choke points, and points with immense gravity.
Gravity wells, pulling resources in.
Yeah. Exactly. And the key takeaway from this first section, really, is that the issue isn't primarily individual failing. It's the structure of the web itself. And the math pretty much dictates the outcome.
Wow. Okay. And this is where the chapter delivers its first really impactful realization, one that forces you to completely redefine your position in the whole global economy. I actually want to read this first quote directly because it changes everything about how you might see your career path. Okay, here it is. Awu are not a player on a level Keldi. Aru are a node in a WTY, and the structure of that WT matters more than anything you do within it. Aurai in the age of intelligence, Wapology is destiny.
Topology is destiny. That statement is just. It's monumental because it takes the whole concept of economic success out of the realm of, say, philosophy or individual will and puts it squarely into physics and mathematics.
So if topology is destiny, it means the network isn't democratic at all.
Not in its structure, no. It's built on something called power laws.
Okay, hold on. Power laws. That sounds deeply technical. Can you unpack that a bit? What is a power law in this context, and why does it automatically lead to this kind of unequal distribution? Because, if I'm listening, my first instinct is probably, okay, but if I'm smart and I work really hard, why can't I just become one of those hubs?
That's a really crucial question. So a power law basically describes a relationship where a very small number of instances, or nodes in this case, have disproportionately huge results. It's completely different from a normal distribution, the classic bell curve, where most things cluster around the average.
Right, the bell curve is familiar.
A power law gives you more of a slippery slope or maybe a cliff shape on a graph.
Yeah.
A tiny percentage of nodes, the hubs, end up commanding almost all the resources, all the connections, all the attention, while the vast majority remain out on the periphery as spokes.
And this isn't just, like, bad luck.
The book argues it's not coincidence at all. It's the mathematically inevitable result of how networks tend to grow. And we see this principle everywhere in the digital economy. The book backs this up with some pretty startling data points. Think about content creation online, YouTube, TikTok, Twitter, whatever. It's consistently found that something like 1% of users generate around 90% of the content, or get 90% of the views and engagement.
1% gets 90%.
Or look at venture capital, startup funding. The book cites that only about 21% of venture-backed startups end up capturing 41% of all the available funding. It's never 50-50. It's always skewed 90-10, 80-20, sometimes even more extreme like 9-91.
And the ultimate example.
Wealth concentration itself. The fact that the top 1% globally holds around half of all stock ownership. These statistics aren't just minor market glitches or anomalies. The book frames them as fundamental evidence that the underlying topology, the very structure, is designed for concentration, not for equal distribution.
Okay, so if the network structure itself is the problem, how does this concentration actually happen? Like, what's the specific mechanism? What ensures that the top 1% always pulls resources away from the other 99%?
The mechanism is what mathematicians call preferential attachment. It's basically the engine that drives these power laws into existence.
Preferential attachment.
Yeah, it works kind of like this. Imagine a new node enters the network. This could be a person joining a social platform, a new company starting up, a new piece of software being released. That new node is overwhelmingly more likely to connect to nodes that already have many connections.
Ah, okay, like joining the most popular group.
Exactly. Or think about a city highway system. When they build new roads, where do they connect them? Usually to the existing, already busy junctions and interchanges. Why? Because that's where the traffic already is. This makes those central junctions even busier, even more powerful. They don't usually build major new roads just connecting two tiny, previously unconnected hamlets out in the sticks.
So it's literally the mathematical inevitability behind that old saying, the rich get richer.
Precisely.
Yeah.
The book makes a point of saying this concentration happens, and I quote loosely here, not through moral failing tut, through mathematical inevitability. It doesn't require some grand conspiracy or, inherent evil. It just requires the physics of connectivity playing out. If you happen to start out with even a tiny advantage in connections, this preferential attachment mechanism ensures that advantage compounds, often exponentially over time.
And the real-world example the book uses to really drive home this difference between individual skill and network topology. It's one of the most memorable parts of the chapter, I think.
The Zuckerberg versus Tebish comparison.
Yeah. Let's look at that contrast. Two programmers, both active around 2004. First, you have Mark Zuckerberg, a sophomore at Harvard, just starting Facebook. Now, the book readily concedes that thousands of people globally, maybe hundreds of thousands, could probably code better than him at that time.
Sure, technically skilled programmers were abundant.
But what did Zuckerberg have? Topology. He was physically at Harvard, surrounded by people who would soon go on to run global finance, law, politics. When he needed seed capital, who was nearby, Peter Thiel, the founder of PayPal, was just, as the book puts it, 2 connections away. That's prime network real estate.
Incredible access, right from the start.
Now, contrast that central hub position with the second programmer. Desh, a superior programmer in Pumtai, working at the exact same time. Tebesh, the book suggests, might have been technically superior. Maybe his code was cleaner, his architectural ideas potentially better.
But his network.
Exactly. When Tebesh looked for funding or mentorship, where did his connections lead? Probably to local businesses, maybe some regional banks, a few domestic Indian contacts perhaps. His network position is topology. It was poor compared to Zuckerberg's. He was on the periphery.
And the outcome difference is stark.
It's brutal. Zuckerberg becomes a multi-billionaire, fundamentally reshapes global communication, and Tebesh, despite potentially superior skill, remains anonymous, financially constrained. That story just makes it impossible to argue that skill alone is enough. It hammers home the point. Your location in the network, your topology, is your destiny.
And it raises a really profound, maybe even disturbing point for anyone listening, right? If you spend years, decades maybe, honing a specific skill, programming, writing, design, consulting, whatever it is, but you apply that skill Within an economic structure, say a big hub-and-spoke platform like Amazon Marketplace or Upwork, where you're fundamentally stuck out on a peripheral
Yeah.
spoke, then your effort, however brilliant, is largely being leveraged to enrich the central hub. It happens automatically, structurally. Your skill is rivalrous. You can only do so much in a day, and it's finite. But the hub's network effect, its ability to connect and extract value, is non-rival and potentially exponential.
That's a tough pill to swallow.
It really is. It forces a reevaluation of where effort is best spent.
Okay, so we've established that this network structure, through preferential attachment, inevitably concentrates power and resources. Now let's take that geometric structure, that topology, and apply it to maybe the biggest macroeconomic mystery, or at least debate, of our time. That persistent, often crushing gap between what people earn from their labor versus what capital earns on its own.
The whole R versus G debate,
Mhm.
famously highlighted by Thomas Piketty.
Exactly. And this brings us straight to the second core quote from the chapter, which directly addresses Piketty's monumental work. Let me read this one. Z.I.Eddy trilliantly documented the symptomi of physics of network. Topology reveals the disease, a fundamental mismatch between the linear world of human e-toward and the exponential world of non-rival capital I.
That hits hard. It's saying, look, Piketty did an incredible job showing that it happens that the rate of return on capital, R, consistently outpaces the rate of overall economic growth, Piketty.
Which means the wealthy who own the capital just get richer faster than workers whose income is generally tied to growth.
Right. Piketty saw the symptom. He documented it meticulously. But this book argues that network topology, the physics of these connections, actually reveals the underlying disease. It's a physical mismatch causing that formula to be true.
A physical mismatch. Okay, if the problem is physical, not just, say, policy or market choices, then we probably need to look back at that three flows concept the book introduced earlier. Specifically, how G and R relate to those flows. Can you break down how those two primary value flows are structurally different and why that difference inherently creates the RG problem?
Absolutely. The core difference boils down to linearity versus exponentiality. It's fundamental. First, you have what the book calls gradient flow. This is directly tied to G economic growth, wage labor. This flow involves rivalrous goods and human effort.
Rivalrous meaning, if I use it, you can't.
Exactly, like your time and physical effort. If you're a chef, a consultant, a construction worker, a driver, your effort is linear. You trade, say, 10 hours of your rivalrous, finite time for roughly 10 hours worth of pay. You can only work so many hours in a day. You can only be in one place at one time. The rate of value you generate is relatively slow, predictable, and ultimately finite. That's the world of G.
Okay, linear, finite human effort. Got it.
Then second, you have circular flow. This is where Y lives the return on capital, which often grows exponentially. This flow deals heavily in non-rival capital.
Non-rival. So things like ideas, software.
Precisely. Intellectual property, software code, network effects themselves, brand reputation, data. Think about it. If you write a brilliant piece of software or create a really popular online course, you write it or record it once that's the initial rivalrous effort. But then it can be sold or used by 1 million people, maybe 10 million simultaneously, without degrading the original product.
Right, selling another copy costs almost nothing.
Exactly. It requires minimal or zero further rivalrous effort from the creator for each additional user. The value scales non-linearly. It compounds. That's the exponential world of the R.
Okay, so the magic, or maybe the curse of the network center, the powerful hub, is that it's structurally positioned, just by its geometry, to capture those compounding, potentially infinite exponential returns of the circular flow.
That's exactly the argument. The center of the network, the hub, naturally absorbs and accumulates the compounding interest generated by non-rival capital and network effects. Meanwhile, the vast majority of participants, the individual workers, the small businesses, the peripheral spokes, they're largely stuck in the slow, grinding, linear world of gradient flow, the world of G.
And the exponential rate will always eventually overwhelm the linear rate.
Mathematically, it has to. And here's the really terrifying realization the book throws in. AI is basically pouring rocket fuel onto R.
How so?
Because AI is becoming incredibly adept at creating valuable non-rival capital algorithms, insights from data, automated systems faster and often better than humans ever could. And at the same time, AI is automating away many tasks that were previously part of G, collapsing the value of that linear human effort.
So the gap isn't just persistent, it's widening, accelerating.
It's becoming an abyss. The book argues AI dramatically amplifies the R side of the equation while simultaneously crushing the G side for many people.
Wow. Okay, that makes Piketty's original findings feel almost quaint or gentle compared to the structural forces described here. He noted the problem. This framework explains why the problem is basically mathematically unstoppable under the current network architecture.
Yeah, it shifts it from an economic observation to a physical inevitability of the structure.
So let's dig into that architecture itself then. The book outlines three fundamental network topologies. Understanding these seems crucial because this is where you, the listener, might be able to identify which kind of riverbed, so to speak, you're currently flowing through economically.
Yes, understanding these three basic structures is absolutely key to figuring out your own economic fate within the network.
Okay, let's start with the one we're probably most familiar with, especially today, the one that really defines big tech and much of the modern platform economy. One, hub and spoke, the extraction engine.
Right, this is the classic centralized architecture. Think of a wheel, one strong hub in the middle and many spokes radiating out. It's defined by its extreme efficiency at funneling value towards that central hub.
Efficiency for the hub, maybe not the spokes.
Precisely. The goal of the hub is to maximize extraction from the spokes. And critically, the spokes, whether they're users, sellers, drivers, content creators, are often interchangeable and relatively powerless. Why? Because they depend on that central hub to connect them to the wider network, to customers, to opportunities. They don't own the connections themselves.
And the example the book uses is, well, it feels chillingly accurate for how a lot of modern commerce operates. It calls platforms like Amazon Marketplace or Uber or maybe even app stores digital sharecropping.
The powerful analogy, isn't it? Amazon is the hub.
Yeah.
Third-party sellers are the spokes. The sellers provide the actual products. They handle the inventory risk, the initial logistics, basically. They provide the rivalrous effort. But Amazon owns the customer relationship. Amazon sets the rules of the marketplace, controls the search algorithms, dictates the fees, and takes an ever-increasing cut of every transaction that's the non-rival platform rent, the R. The harder the individual sellers work, the more data Amazon gathers, the stronger its algorithms become, the more powerful its central hub position gets. It's an incredibly efficient extraction engine.
But it leaves the spokes, often the human participants, vulnerable, interchangeable, and with very little leverage to negotiate for better terms or build their own independent brand equity.
Exactly. That's the nature of the hub and spoke beast when it's designed for extraction.
Okay, moving on to the second type described. 2, small world, the innovation engine. What does that look like geometrically, and why is it labeled the innovation engine?
Geometrically, you can imagine several tight clusters of nodes. Think of dense little groups where individuals inside are highly connected to each other. And then these dense clusters are only occasionally linked together by longer bridge connections that span across the network.
So like tight-knit teams or communities connected by a few boundary spanners.
That's a great way to think about it. And innovation tends to thrive in this structure. Why? Because ideas can circulate really intensely within a tight cluster, allowing for deep dives and specialization. But then occasionally, those highly refined ideas bump into a very different idea coming from a distant cluster via one of those long bridges. It's where specialized knowledge collides with other specialized knowledge.
So maybe Silicon Valley isn't just one giant hub, but maybe a collection of these small worlds, clusters of specialized venture capital, clusters of AI talent, clusters focusing on biotech, all loosely connected.
Precisely. The book suggests this is often where breakthroughs happen. However, and this is crucial, it's also a massive concentrator of rewards.
How so?
Because being inside the right cluster at the right time, and maybe more importantly, having access to those key long bridges that connect you to other valuable clusters, that's everything. If you're outside that specific small world network where the action is happening, your chances of participating in that wave of innovation and capturing any of its exponential returns are basically zero.
So it drives innovation, but also locks the rewards within those specific high-density clusters.
Exactly. It's an engine for innovation that also inherently concentrates wealth among those positioned correctly within its topology.
Okay. And finally, the third structure, the one the book seems to hold up as potentially a solution or a better model. 3, distributed mesh. The resilience engine.
Right, the mesh. Picture a fishnet, or maybe the way neurons connect in the brain. Every node connects redundantly to multiple neighbors. There is no single center, there's no hierarchy. And because of that, there's no single point of failure.
Decentralized and redundant.
Totally. The ultimate example often cited is the structure of the Bitcoin network, or the original architectural design principles of the Internet, ARPANET. It's incredibly good for survival, for community building, for distributing information widely and robustly. If you somehow destroyed half the nodes in a true mesh network, the other half could continue to function, just routing information around the damage instantly.
That sounds really robust, resilient, as the name suggests.
It is. But, and here's the critical trade-off, the mesh topology is inherently terrible at concentrating capital.
Ah, why is that?
Because there's no center for value to flow towards and accumulate. Value tends to distribute throughout a mesh. It doesn't pool in one place. So the book concludes, if your goal is to build a highly profitable corporation based on maximizing extraction and shareholder value, you'd probably choose a hub and spoke model. But if your goal is to build a resilient, decentralized community or a robust piece of infrastructure that can survive attacks or failures, you'd choose the distributed mesh.
So it's the topology of communities, maybe open source projects, but not the typical structure of modern corporations seeking profit maximization.
That's the core distinction the book draws. The structure you choose dictates the outcome: concentration versus distribution, efficiency versus resilience. And this is where things get particularly concerning, because that hub and spoke model, the structure already so good at extraction, is now being optimized, turbocharged, and perfected by artificial intelligence.
Right.
And the structural acceleration, the book argues, is leading us directly towards something it calls the Great Exclusion.
The Great Exclusion. That sounds ominous. And this connects back to AI inverting that old rule, right? Historically, if a business got really big, it often got slower, more bureaucratic.
Yeah, organizational friction, communication overhead, those things acted as a kind of natural brake on runaway concentration.
But the book argues AI has completely flipped that. How does AI turn concentration into this, like, accelerating spiral?
It creates a powerful positive feedback loop. The book uses some pretty vivid analogies: an accelerating spiral that approaches singularity, or even gravitational collapse.
Gravitational collapse, like a star collapsing into a black hole.
Exactly, that kind of physics analogy. In simple terms, it works like this. The bigger the network platform gets, think Google Search, Amazon, Facebook, the more data it generates from user interactions. The more data it has, the better its machine learning models become at predicting, recommending, optimizing. The better the AI models, the better the user experience, which attracts even more users.
Which generates even more data.
Exactly. It's a cycle that feeds itself. This ensures that the largest player doesn't just grow incrementally. It grows exponentially faster than any potential competitor and effectively locks them out.
It becomes impossible to catch up because you can't get the data needed to train a competitive AI.
Precisely. Think of it like that black hole analogy. The gravity, the network effect, combined with the data advantage, becomes so intense that nothing, not even light, or in this economic case, a potential competitor with maybe even better initial tech, can escape its pull once it gets too close. That advantage of scale, which used to be somewhat offset by internal human bureaucracy, is now amplified almost infinitely by AI's ability to process and learn from that scale.
And the specific example used, Google search, really hammers this home, doesn't it? What is it? Something like 8.5 billion searches every single day.
Around that, yeah. An astronomical number.
And the book points out something crucial. Every single one of those 8.5 billion searches isn't just a user asking a question. It's a high-fidelity training data point for Google's AI.
Yes. Every typo, every reformulation of a query, every click on a result, every time someone doesn't click, it all feeds back into the algorithms. Google's AI learns from every single interaction, making the next search slightly more accurate, slightly faster, slightly more relevant.
So a competitor, even if they somehow developed a technically superior search algorithm from scratch today,
they could never realistically catch up. They simply cannot access the decades' worth of proprietary behavioral data derived from Google, having already won the market and operated at that massive scale. The topology, Google being the central hub for search, became destiny. And once that data-fueled gravity well forms, it becomes almost absolute, enforced by these massive data moats that AI continuously deepens.
And this isn't just Google, right? This applies across the board.
The book argues this phenomenon applies to basically every large network-based platform. Social media, e-commerce marketplaces, cloud computing services, streaming platforms. Once a dominant hub-and-spoke network is established, and AI is put in charge of optimizing the flows within it, the system tends to become closed, self-referential, and almost unbeatable through direct competition within that same model.
Okay. And this is what leads us to Maybe the darkest realization in the entire chapter, the one that directly connects all this abstract topology talk to the daily reality and future prospects of the listener. This is the third key quote. We are not teeing outcompeted I. We are teeing structurally occluded I, economic network, is rewiring itself to remove humans from the center.
Let that sink in. The difference between being outcompeted and being structurally excluded is it's massive.
Explain that difference. Being outcompeted feels like, okay, I lost a fair race. Maybe I wasn't fast enough or skilled enough.
Right. It implies you were on the track, you had a chance.
Yeah.
But being structurally excluded means the rules of the race were changed while you were running. Maybe the finish line was moved behind a locked gate, or perhaps you weren't even allowed into the stadium to begin with.
Yeah.
The structure itself prevents your participation.
And the book argues that's what's happening. Humans are becoming, what was the phrase, topologically irrelevant.
Yeah. Topologically irrelevant. It's a chilling phrase, and it requires some unpacking. How does a human or humanity collectively become irrelevant to the economic map?
Ow.
Well, think about the old economy, even just 20 years ago. Value largely flowed human to human, maybe mediated by a corporation. But humans were essential nodes. We did the selling, the negotiating, the relationship management, the creative work, the core decision-making.
We're in the loop.
We were the loop in many ways. But in this age of AI-optimized hub-and-spoke networks, value increasingly flows. Well, AI to AI. Machine to machine. It happens through APIs, through algorithms, talking to other algorithms directly on the platform's infrastructure. The system becomes so efficient at optimizing these automated flows that the messy, slow, unpredictable, high-latency human actually becomes an impediment to peak efficiency.
An impediment, wow.
Think about, say, the Amazon delivery process again. You click buy, okay, human input there.
Yeah.
But the recommendation engine, AI optimized. The inventory allocation in the warehouse, AI optimized. The route planning for the delivery truck, AI optimized. The pricing adjustments, AI optimized. Where are the humans in that core flow?
Mostly at the very beginning, clicking buy, and maybe at the very end, the delivery driver.
Exactly. We're increasingly relegated to being either the high-latency data source, the initial command or request, or the final physical endpoint, like the last-mile delivery driver handling the messy physical world. We become the edge of the network, not the center. And the algorithms running the core are constantly being designed to minimize reliance on that slow, expensive human edge.
So it's not just that AI might take your specific job function. It's that the entire system is rewiring itself to bypass the need for human interaction within the core value creation exchange process altogether.
That's the essence of structural exclusion as the book presents it. If the hub-and-spoke model becomes fully automated, running AI to AI, then the human spokes, the suppliers who used to interface with buyers, the creators who pitched ideas, the service providers who negotiated contracts, they might simply no longer be necessary for the core economic transaction to complete within the platform. They are bypassed, routed around.
That is structural exclusion. You're outside the value flow.
And this whole process is massively reinforced by that RG physics we talked about. If all the exponential returns are being captured and amplified by the automated core of the network, and the value of linear human effort, G, is being driven down towards zero by automation, then the system, while becoming hyper-efficient for the hub, has less and less topological need for widespread human participation in wealth creation itself.
That's a profoundly challenging vision of the future.
It absolutely is. It questions the fundamental role of human work in an AI-driven economy.
Okay. This has been, a deeply challenging deep dive so far. The picture painted is pretty bleak. Mathematical inevitability pushing towards concentration, network physics favoring capital over labor, and now AI accelerating this whole process towards, well, structural exclusion for many.
It's not exactly uplifting, is it?
Not really. So the big question becomes, if the system, the network prison, is really built on these seemingly immutable mathematical and physical laws, are we genuinely trapped? Is there any escape hatch? Is resistance futile, basically?
Well, the book argues quite strongly that no, we're not necessarily doomed. There is an escape strategy, but, and this is key, it's not about fighting the existing rules from within the prison. It's about changing the game entirely.
Okay, how?
The core strategy is laid out very clearly in the book. It says, "I do not teat a network. Tai competing within it. I co-teat it. Tai tilting a different one art. I'll route around it."
Root around it. Don't fight the giant. Build something else somewhere else.
Exactly. That's the critical shift in thinking. The book argues, look, if you try to build another massive hub-and-spoke network to directly challenge, say, Google in search or Amazon in e-commerce, you're almost certainly going to lose. Why? Because their existing network effects, their data moats, their AI optimization, that gravitational collapse mechanism is already too powerful. You can't beat them at their own game on their own turf.
So you have to build something with an entirely different structure.
Precisely.
Yeah.
Something with a fundamentally different topology. Something that perhaps prioritizes distribution, resilience, community ownership over centralized extraction and maximum scale. You have to build it using a different architectural blueprint.
And the book uses a really interesting historical parallel to demonstrate this pattern of network disruption, right? The Protestant Reformation. That seems like a leap.
It might seem like one at first, but the structural parallel is actually perfect. Think about it. In the early 16th century, the Catholic Church was arguably the ultimate hub-and-spoke network in Europe.
House.
It controlled the central theology hub. It controlled the language hub, Latin. It controlled the network of authority through bishops and priests radiating outwards. It was, for all intents and purposes, structurally unchallengeable from within.
Okay, I see the hub and spoke structure there.
Now, what did Martin Luther do? He didn't try to climb the existing hierarchy to become pope and reform it from the top down. He didn't just try to get a slightly better deal for his local parish spoke. No. He routed around the entire existing network.
How?
By leveraging a disruptive new technology, the printing press, to decentralize access to information. And by translating the Bible into local vernacular languages, suddenly you didn't need the central church hub in Rome or the local priest spoke to access scripture or theological debate. He effectively helped create thousands of alternate distributed nodes of authority, local parishes reading in their own language, individuals interpreting scripture for themselves.
So the old hub wasn't necessarily defeated head-on.
It was rendered less relevant. It was bypassed by a newer, more distributed, arguably more resilient topology for disseminating information and building community. The pattern, the book argues, is clear. You route around the dominant extractive network.
Okay, that makes the goal much clearer. The solution proposed is conscious topology construction. We need to deliberately, actively build networks that resist that default tendency towards hub-and-spoke extraction, networks that are perhaps more like the distributed mesh or maybe innovative small worlds, consciously avoiding that centralized architecture.
That's the core idea.
But that still sounds incredibly abstract. For the average person listening, what does conscious topology construction actually mean in practice? What can someone do?
Yeah, it's easy for it to sound abstract. But it translates into making deliberate, often strategic choices about where and how you connect, interact, and expend your effort in the economy. It means consciously choosing interaction models and platforms that prioritize things like resilience, data ownership, equity, and distribution, rather than just opting for the path of least resistance, which often leads to the most centralized, extractive platforms.
Can you give an example?
Sure. Think about a creator, a writer, musician, artist, programmer. If you put all your work, all your audience engagement solely onto one massive centralized hub-and-spoke platform, say, only on YouTube or only on Facebook or only selling through Amazon, you're essentially making yourself an interchangeable digital sharecropper.
Yeah.
You're a spoke dependent on the hub's algorithms and rules.
Vulnerable.
Conscious topology construction, in that case, might mean actively diversifying. It could mean leveraging open protocols where possible. Maybe building your own direct audience list. Perhaps participating in or building platforms with distributed ownership models like cooperatives or DAOs, decentralized autonomous organizations. It means ensuring your value, your connections, your reputation are routed through multiple redundant pathways, some of which you ideally control or co-own. You're trying to build your own mini-mesh or connect to existing ones.
So it's about actively choosing connection strategies that build resilience and distribute power, rather than just plugging into the biggest, easiest hub.
Exactly. It requires more conscious effort, definitely. It might be less efficient in the short term. But the goal is long-term resilience and avoiding that structural exclusion.
This shift in thinking about architecture is so fundamental, the book even connects it back to the structure of human intelligence itself. It suggests the ultimate goal might be for our economic topology to actually mirror the most successful, complex, and resilient system we know, which is the human brain.
Yeah, the comparison is pretty fantastic when you lay it out. Let's quickly review those three structures again, but through the lens of intelligence or organizational models. Think about a traditional rigid corporate hierarchy. That perfectly mirrors the hub and spoke model, right? Command and control flows from the center, the CEO, the board. It can be efficient for executing specific top-down directives, but it's also incredibly brittle and often profoundly unintelligent as a whole system. If the CEO or the central hub makes a bad decision, the entire organization can collapse because there's no redundancy or distributed sense-making.
Okay, hub and spoke equals brittle hierarchy.
Now, consider the core mechanism behind modern generative AI, like the transformer models that power things like ChatGPT. The book suggests this operates much like a highly effective small world network. Its attention mechanisms allow different parts of the data, different concepts, to quickly find novel, sometimes long-distance connections between disparate ideas. That's what drives the surprising innovation and creative breakthroughs we see connecting clusters of knowledge.
Interesting. Small World uses AI like innovation engine.
But then you get to the human brain, the absolute pinnacle of consciousness, adaptability, and resilience. The book argues the brain is a masterpiece of distributed mesh architecture.
How so?
It's just infinitely complex and interconnected. Countless neurons, countless redundant connections. There is no single CEO neuron. There's no single point of failure that takes down the whole system. It's massively decentralized. If one area of the brain is damaged, other pathways often reroute and take over the function, maybe imperfectly, but the system adapts.
Resilience through redundancy and distribution.
Precisely. And here's the kicker. The brain is demonstrably less efficient than, say, the fastest computer chip when it comes to performing simple, narrow-focused calculations. A chip is faster for that specific task, but the brain is infinitely more resilient, more adaptable, and capable of nuanced general intelligence and consciousness.
So the argument is, if we build our economies like brittle corporate hierarchies, hub and spoke, they will be brittle and prone to systemic collapse, especially under stress.
But if we consciously choose to build them more like the decentralized, redundant, resilient architecture of the human brain, aiming for distributed mesh principles, we stand a much better chance of achieving long-term survival, adaptation, and maybe even a more equitable prosperity.
Wow, that's a powerful concluding thought for the section. So maybe we want to leave you, the listener, with this final practical thought to mull over today, something concrete to reflect on. Considering that the human brain itself seems to prioritize resilience and adaptability over raw, short-term efficiency, what active conscious choices could you make, starting today, to begin shifting your own professional life, maybe even your social connections, away from relying solely on brittle hub-and-spoke extraction models, where your primary effort enriches some distant, centralized hub, and more towards building or participating in resilient, distributed mesh-like structures, where value flows more redundantly, perhaps more locally, and where you have more agency and robustness?
Yeah. Are you investing all your time and energy in becoming a hyper-specialized, easily replaceable spoke? Or are you consciously building diverse, redundant connections and skills that ensure your personal and professional resilience, even if it seems less optimal in the very short term? That's the strategic question topology forces us to ask. Hashtag outro Grace.
All right, that was a lot. To try and bring this entire, quite dense analysis of Chapter 10 together into just a single powerful sentence. The main argument is that economic inequality and the increasing threat of human obsolescence are not just random market failures or policy choices, but are the inevitable structural result of mathematical power laws that naturally turn our global economic network into an extractive prison, a situation that AI is now accelerating towards its final, perhaps unavoidable conclusion under the current paradigm.
Yeah, that captures the weight of it. And just to bullet point the absolute key takeaways from this deep dive, the things you really need to remember. First, topology is destiny. Your structural position within the economic network dictates your financial fate far more significantly than your individual skills or effort, mainly due to the physics of preferential attachment.
Okay.
Second, the RG mismatch is a physical problem. That persistent gap exists because exponential returns on capital R, which thrive in non-rival networks amplified by AI, are structurally designed to overwhelm the linear returns available from finite human effort. AG, it's a structural imbalance.
Got it.
Third, the rise of AI is driving a great exclusion. This isn't just about job replacement. It's a profound structural shift, making humans increasingly topologically irrelevant as core economic value flows more and more AI to AI through hyper-optimized closed platforms, effectively bypassing the human node.
Right, the bypassing is key.
And finally, maybe the most important takeaway, the only viable solution is conscious topology construction. Since you can't beat the giant hub-and-spoke networks at their own game, the strategy must be to actively route around them by building or joining alternative, resilient distributed mesh networks that prioritize community, decentralization, and robustness over pure extraction and centralized profit.
build different networks, rid around it. That seems to be the core message of hope, or at least agency here. That's definitely a lot to process from Chapter 10. Next time, we're going to move from this diagnosis of the network prison to exploring the potential architecture of a new economy, delving into Chapter 11 titled The Cathedral and the Bazaar 2.0.
Ah, yeah, that's a classic metaphor reimagined.
It is. We'll look at why the book argues the traditional company, the hierarchical, slow-moving, centrally planned cathedral, is becoming an evolutionary dead end in the age of AI, and how the economy might already be evolving into something much more like a fluid, dynamic, sometimes chaotic, but highly collaborative bazaar of computation and intelligence.
A decentralized marketplace of ideas and execution.
Exactly. And we'll explore what that potentially profound, maybe messy shift means for the future security and even the very structure of your career and work life. Thank you for joining us for the deep dive. We'll see you next time.